So our question is, iron exhibits BCC structure at room temperature. Above 900 degrees Celsius, it transforms to FCC structure. The ratio of density of iron at room temperature to that at 900 degrees Celsius. So it's given assuming molar mass and atomic radii of iron remains constant with temperature is. So we have to see what all is given in the question. It says above 900 degrees Celsius, it transforms to FCC structure. Then the ratio of density of iron at room temperature to that is 900 degrees Celsius. So what we will do in this question, we will see, we know the formula of like finding D, that is density. So it is Zm a to the power 3 n naught. So for BCC we know that Z is 2, and for FCC similarly we know that it is 4. It is for BCC, it is for FCC. So also we know that A equal to A is our edge length. A is 4 by root 3r. 4 by root 3r. And also here A is for FCC 4 by root 2r. So what we will do here is, we have to do nothing, but we have to put the equation of BCC in the given formula, and also the equation of FCC in the same formula. So after putting BCC in this formula, we will get 2m 4 by r 4r 4 by root 3r and here 0, and for the FCC we will get 4m 4 by root 2 r 4 by root 2 r 4 by root 2 r. It is cube. I forgot to mention it. It is for cube here also as given in the formula, and similarly n. So what we will do here is, we will divide the first equation. This is our first equation. This is our first equation. This is our second equation. We will divide these equations 1 and 2. So we will find, after solving this, we will get the answer 3 root 3 4 by root 2. So we will see here that it is the very first option given. So this is our answer. Thank you. BCC structure.